All right. So we have our Canvas page. I put a announcement and what looks like an assignment up yesterday. There's nothing really attached to it. You might be like, what's going on? So the corrections that I'm going to allow you to make, I will, when I get back to my office today at 2, post the answer keys as well as the exams themselves. So you should have had which exam you had, right? A or B. If you're not sure, I think it should be on the top right corner of all of them. If not, and you forgot to, you left it off, email me and I'll let you double check which form you had. But you can go through that answer key and determine which ones you got incorrect, right? So you'll essentially go through and kind of grade your own exam and determine which ones you got wrong. Right? Once you see the ones that you got wrong, basically go through and correct those. Provide me an explanation as to why you got it wrong and as to what the correct or why the correct answer is what it is, right? I'm giving you the answer, so you should be able to get that. Now, what I don't want to see and what the announcement kind of said, or what it kind of had in the description or the instructions is, if I have a question that says something like, the number of consumers went up, which of the following occurs? Does demand increase or decrease? Does supply increase or supply decrease? If you got it wrong, well, the correct answer should be maybe A, that demand increase, right? You cannot simply say the answer is C because when demand increases. You have to give me some explanation as behind why. So when there's more consumers, right, there's more individuals that are willing to buy that good at any given price, and so we see this increase in the demand, right? So give me kind of a little bit longer of an explanation. Don't just state the answer is C. I know the answer is C. That's not going to help you at all. The point of these corrections is to go back through, and as you're reworking them and writing up why your answer was wrong and why the correct answer is, the correct answer, it's going to be kind of hopefully like a learning process, right? If that, you shouldn't simply hand me back a thing that says the correct answer is C. It doesn't show me that you learned anything through this process, right? So I need to see some type of an explanation or support. And for some of these, it might be drawing a graph, right? You could draw a little graph to help explain why the correct answer is right, what it is. Maybe some of the equations, right? You just rework the equations and show me your work, right? As to how you got to the correct answer, right? So some of them will be a little bit easier probably than others to correct. Some of them might require a little bit lengthier of an explanation, okay? Like I said, any of these really, you can draw some graphs for a problem. That's also great justification or support, right? Give me a nice visual. Okay? So you go through and make these corrections, right? I'll give you half credit back on every problem you correct. So it might not sound like a lot, but if I'm looking at my grade and I got a 50, if I do the questions I got wrong and make all my corrections, I can get 25 points back. I can raise my grade from a 50 to a 75, which is a significant difference. Okay? Even those of you who did better, right? I would still highly suggest going through, making those corrections and getting back as many points as possible. It shouldn't be, especially if you did well, it wouldn't be, take you near as long. So I would suggest it for everybody, right? Any questions on that? I'm kind of expecting there to be, so don't feel like you can't ask it. Yeah. Yeah, if you want if you did any work on the side and you want to see that, I have those all in my office. You could either stop by this afternoon during office hours from 2:30 to 3:30, or if you want to stop by sometime tomorrow, just let me know. I'll be around the building most of the day. Just send me an email and I'll make sure I'm in my office when you stop by. Okay.
So do you want these submitted?
Oh, yes. So you can make these corrections and you can hand them. So it's due at the end of the day on Friday, right? So you have a very short window to do this, right? But we don't have a homework going on right now. I think I said last class I put a homework up. I purposely didn't so that you could just focus on these for the next couple of days and get them out of the way. Now, you can hand them in class Friday if you want to. If it's easier for you to do it before class, by the time we meet on Friday and hand it in, that's fine. If you want a little bit more time on Friday, or you just you got it done, you don't want to hold on to it and lose it, and you just want to upload it as either a picture, a PDF, or even if you want to type out kind of your work or in Word. So a lot of I'll tell you a really nice way to do it. If you are able to. You take pictures of like your work, and then anything you want to write out, you can type it out in Word. You can copy and paste those pictures in Word as like kind of like one file. It's a lot easier for me to see it. But if you just want to upload like pictures of your work, that's fine as well, or a scanned PDF version of your work. However you want to do it, all those are available options to kind of upload to here. Does that answer your question?
We need this back.
I don't need those back. I can see the number of questions and which questions you got incorrect, so I know which ones that you need to do. If when you're going through, you kind of grade your own, figure out which ones you got wrong. For whatever reason you can't figure, if you want to double check, shoot me an email and I'll double check for you real quick. Yeah. I forget exactly what it was. It wasn't good. Wasn't good. One thing I noticed, is that I think, I went through and there was some questions that a lot of people got wrong, but it was a little bit kind of towards the middle to the last half of stuff that we covered. I think surplus and the regulations gave people a lot of trouble. So I think the average was just below 60. But I kind of had this idea in mind. So when I originally told you I was going to do short answer, I was actually thinking of potentially doing a short answer project to earn points back. Sometimes I have an exam where I know it's a little bit, maybe, I didn't think it was necessarily going to be tougher, but I could tell that some people were kind of, the majority of the classes were having trouble with kind of things here and there. So I had an idea kind of already in the back of my mind of how we were going to kind of get those points back if the average being a little bit lower. And this is the process through which I'm going to use. Like I said, I've done it in the past on exams that classes don't do well. And it really can be, if you do it, be a good learning tool, because you're going through and you're understanding on questions that I wrote for an exam, why you got it wrong, why the correct answer is what it is. And so if you go through this process and actually take it seriously, like it'll help you on future exams as well. Right? So I think this is a really valuable thing to do. I'll let you guys know once I get these corrections back. I'll get them graded this weekend, update the midterms, post your grades, and then we'll talk about what the new average is next Monday. Or not Monday, because we don't have class, Wednesday. All right.
Were both of the tests the same and just the questions mixed up?
Yep.
Okay,
Yeah.
I was making sure I was.
No, exact same questions. In fact, I just actually didn't even rearrange the questions. I just rearranged the answers.
Oh.
Any other questions before we get going? All right, so please do this. I hope I have every single person turn in corrections. Like I'm really, really strongly suggesting that you do this. Okay. All right. So with that being said, we left off talking about kind of marginal production. So I went and kind of showed you a really easy example, thinking about production workers and the marginal productivity of each worker, how potentially initially we see this kind of increase in the marginal productivity because of specialization, but eventually we're just hiring less and less capable workers. And so eventually we're going to get to this point where the marginal productivity is declining. So we'll work through a couple more examples of this. So here I've got a little bit more of a difficult example because I'm not just going up by one worker, right? So here I've got kind of this Chipotle example, right, where we've got these different number of workers and how many burritos each one can maybe do in a month or something, or in a week. So if we have 0 workers, right, we have 0 output, right? If we don't have any workers, we can't produce any product. When I hire 1 worker, maybe in a week or a month, right, whatever our time frame is, they're making 1,000 burritos. So I plot that. Next worker, 1,800, so on and so forth, right? So I have all these different number of workers, and when I hire the first worker, I can make 1,000 burritos. Second worker, the total burritos I'm making are 1,800. The third worker, they're all 3 collectively making 2,400, so on and so forth. So what I can start to do is think about if I had all these points and I drew a line to this, represents my production. So I've got my total output, like Q, that was my total output or total production. And I've got the number of workers here. last class we said we can determine the marginal product of those workers. And sometimes you'll see this like marginal product of labor. Sometimes it might be, you see the notation of that as well. And it's really just the change in output from the change in the number of workers, or kind of change in Q from a change in, typically we'll kind of think about this as maybe the quantity of labor, right? Q represents the output of whatever product we're interested in. Here it's burritos. QL, remember, that was our kind of quantity of labor, the number of workers we had hired. So here again, we have an example where it goes up by 1. So it should be relatively easy to figure out the marginal product for each one of these workers. So I hire that first worker. What's the marginal product of that first worker? Yeah, he added 1,000, he or she added 1,000 burritos, right, to my production. If I then hire that second worker, what's the marginal product of that worker? Well, how much did the output go up by? That's the marginal product of the second worker. What about the fifth worker? What's his or her marginal product? Yeah, right. Going from that fourth to that fifth worker, a change in my workers was just 1, so that makes that easy. The change in my output was 200, so I've got kind of the marginal product of that fifth worker being 200. So we've got this marginal product of labor, right, or MPL. So sometimes this denominator is a little bit more difficult to deal with. Like here we had examples where we're just going up by 1, but maybe I only see the data presented like in tens, right? So sometimes the change in workers doesn't necessarily have to be 1, which makes my life a little bit more complicated. And I think I've got an example on the next slide of that. Okay. But we still determine marginal product the same way. Change in output divided by the change in labor. Okay. We already kind of talked through this, but here's like a nice screen where you can go through and determine the marginal product of each one of these workers, right? So here's the first, second, third, fourth, and fifth workers' marginal product of labor. Right? We kind of already talked through that. What do I want to say here? I think we talked about this already. If we look at the visual here, go back. Kind of notice my production function or my production curve is like getting flatter and flatter. So this is the idea that the first worker is the most productive worker, right? That's why I hired them first. I found the highest quality candidate and I hired them first. And my second worker was the next kind of quality, like the highest quality candidate, and the third and the fourth. So eventually I'm getting less and less productive workers, right? As I hire more of them. Okay? So again, just kind of flatten the curve. We'll kind of see that play out in the numbers as well. But what we call this kind of decrease in the marginal productivity worker is the diminishing returns to labor. Right? As I hire more and more labor, the returns to me as a company, right, are getting smaller and smaller, right? The marginal product of each worker is declining as I hire more and more workers. And we can kind of see this here, right? We're just getting this flatter curve, right? You can kind of notice the distance in between kind of output for each one of these workers and the number of workers before them, right? Kind of gets smaller and smaller. Any questions on this before we keep going? So that's not too bad. And you kind of can map out here, right? The change in quantity for each one of these workers, and notice it's getting smaller and smaller. So we have this, we have this diminishing returns to labor, which tells us that as we hire more and more workers, right, we're going to see that marginal productivity of labor kind of decline. In the last class we talked about, we may see this initial kind of increase from specialization. In the previous example, I didn't have any of that. But in practice, we usually see kind of this initial increase because of specialization, and then it starts declining. Now, when it comes to what we're actually going to be focusing on, we typically don't focus on that initial portion, mostly because it doesn't influence things like what's the output the firm decides to kind of choose. Because as long as my workers are being more productive, I should continue to hire more and more workers if I'm getting gains from that specialization. So we're usually only concerned about that portion of the curve where it's diminishing, right? At what point are workers, not productive enough to warrant the wage I'd have to pay them, essentially. So I won't use IQ on this specific question, but if we had them like this, right? I've got my different quantities of labor. I've got my different outputs. What would the marginal product for my fifth worker be? So the marginal product is just a change in output from that increase in labor. Well, being that fifth worker, I'm increasing labor from 4 to 5, right? If I'm hiring a fifth worker, I'm going from having 4 units of labor, 4 workers, to 5. So that kind of makes it easier. My change in the number of workers there is just 1. What's my change in output going from that 4th to 5th worker? Just 9, right? So, oh, no, it's not 9, it's 11. I looked at the numbers wrong, right? It's 64 and 75, not 74 and 65, right? So it's just the change in output here, right? The difference between 75 and 64. That fifth worker added 11 kind of bushels of wheat, I guess. Sorry for misspeaking. Any questions on how we do that? That one shouldn't be hard. And I have other questions for later, but let's think of something that's a little bit maybe more difficult, and then we'll have to translate that into costs later as well. So here I've got my different number of workers. Right? So just displaying the information instead of in column form and row form here. I've got my total output. So here I've got where my marginal productivity of labor is declining, right? But I can actually come up with my average productivity of labor as well. So the marginal productivity is the change in output from a change in labor. Average is just take the total quantity of output, or the total output or total quantity, and divide it by the number of workers I'm employing. Right? So notice here, when I get to this third worker, so once I've hired 3 workers, their output is, no, I got way too many zeros there. Hold on. How did that happen? These don't match up with what I had on the other screen, right? There we go. That looks a little bit more reasonable. So we've got these different kind of outputs here. So I've got 2,400 is the total output when I've hired 3 workers. So the average output per worker would be 2,400 divided by 3. To get an average, I just take the total and divide it by, here I would take the total quantity and divide it by the total number of units of labor. So 3 people are making 2,400 burritos. That means on average, each one of them is making 800. But now I know that each one of those works, that's just the average, right? I know that worker 1 actually is adding 1,000 burritos to production. Worker 2 is only adding 800, and worker 3 is adding 600, right? So their marginal product of labor, right, what they're adding to the total is going down. Right? And so my new average, as I hire more and more workers, will also be declining, right? If I initially start out, right, that first worker can make 1,000 burritos, the marginal productivity of that first worker is 1,000. I only have 1 worker, so the average productivity would be 1,000 over 1 as well. Then as I add less and less productive workers, well, if the second worker only adds 800, well, now my new average is going to be a little bit lower than what it was before, right? Because my old, I only had 1 worker who was had a marginal productivity of 1,000. Now I have 2 workers, one with a marginal productivity of 1,000, one who only has one of 800. So you kind of think about it like the average marginal productivity is what we're getting down here when we measure this average productivity of labor, right? The average of those 2 workers' marginal productivity is how I'm coming up with that average productivity as well. So there's really 2 ways of kind of finding the same thing. It's probably easier in practice when you're calculating the average to just take the total output and divide it by the total number of workers you have. You can kind of see as the marginal productivity of labor is declining, so is that average productivity of labor. You know, we kind of have these weird scenarios sometimes where, like, I always use the Chipotle example, like maybe we get to a point where we've got 5 workers, they're each kind of at different points along the line. We then add a 6th worker. Well, how much do they add to production? Well, there's not even really a job for them to do, so they're just standing around. So they literally add nothing to the output, right? So eventually we probably get to a point where that marginal productivity of labor actually is zero, right? It's diminished down to the point where we've got, we've got too many people for our space, right? Or, we're just hiring people that don't really have a job for them to do. So eventually that marginal productivity of labor will get down to zero. So these relationships here, try to give you I think I have a slide maybe. Yeah, so I'll draw this up on the board as well. What ends up being true here's my marginal productivity of labor. Right? If I have this portion where it initially is increasing because of specialization, and really like the average should start at the same place. I don't know if that drawing depicts it right because it doesn't go all the way to the y-axis. But my average productivity of labor looks something like this. So as I add more and more workers, right? So adding more and more workers, this is kind of measuring their marginal productivity. They're adding a higher and higher number of units because of specialization. So every single time I go to calculate my average, well, if I had like, let's say for example, I start out with two numbers, 2 and 4. What's the average of those two numbers? 3. I add them up, divide by 2, I get 3. If I then take something that's higher than 3, so maybe I add a 6 to those two numbers, right? So now I got 2, 4, and 6. Add a higher value than my previous average. What's my new average? So I've got 2, 4, and 6. My new average would be 6. So notice when I'm adding a value, right, to my data set or whatever you think about it, that is greater than the average, my new average will be higher, right? So as I'm adding, higher and higher marginal productivity of labor, as long as that marginal productivity of labor is greater than my old average, my new average will be higher. So eventually I get to this point where now as I add more and more workers, their marginal productivity is now below what my old average was. So now I'm adding values that are less than my average. So my new average is going to be lower and lower. So I didn't draw this doesn't look like I got the peak quite right here. But it should be the highest point of that average productivity of labor curve will be where it intersects that marginal productivity rate. Because that really represents that I'm adding values above my average. So that's going to cause my new average to continue to go up. And then when I start adding values that are lower than my average, then my average productivity labor is declining. So that's kind of what that is going to be reflecting. What we kind of gather from this graph. Does that make sense? Any questions on that? I always think it kind of helps to think about that relationship, starting with just two numbers. Like I did kind of there. 2 and 4, the average is 3. So if I then, the marginal productivity labor was 6, well, my new average productivity would then go up from that average of 3 and will kind of increase. I'm adding a higher number than the average, so it's pulling that average up. So why are we talking about, we started talking about cost last class and said, we're going to be focusing on cost a lot. And then I started talking about all this productivity stuff, right? Well, because behind the scenes, right, when we think about costs, a big component of that is going to be coming from labor, right? We have things like, renting a building and then the machinery we buy. But a lot of those times, those things are a fixed cost. Once we buy them, or I shouldn't say they're fixed, but they are a fixed cost, or it's something that we can't change in the short run, right? So we're going to start eventually talking about differences in short run, long run. In the short run, it's very difficult for me today, if I'm a company, to switch buildings, switch my production facility somewhere else, right? That is a short run, or sorry, I should say that's a implausible short run decision to make, right? Maybe over the course of a month or a year, I can transition to another building, but in the short run, and if you think about the short run as what decisions I can make today, I can't change those things. But what I can change today is I can hire and fire workers a lot easier within a 24-hour time period. Hell, I can fire workers in a much shorter time period, right? But we're going to be thinking about labor then as our short-run cost that we can change. So if I can hire workers, and let's say, I've got this Chipotle example, and maybe this was like per month, I have to pay them $2,000, right? So I've got this cost to rent my space. That's kind of a long run cost. I can't change that in the short run. But my workers, right, are a short run decision. Okay? Well, now the issue is, I can start to think, like, if I start hiring these workers, maybe their marginal productivity is high enough to where they can produce enough burritos to where when I sell them, I'll be making much more than that $2,000 I have to pay the worker to make those burritos. And that's the goal, that my revenues are greater than my costs. But eventually, if I keep hiring workers, some of these will end up being not very productive, but I still have to pay them that same wage. If it's easier for you to think about it in this context of this example, let's assume everybody at Chipotle kind of working that same position is making the same wage. Well, some of those workers are really, their output is justifying that wage, but then my lower quality workers who aren't adding a whole lot to my output, right? They might not justify that. So what's my optimal number of workers to hire? Right? It's basically what we can kind of start to think about. So let's start calculating costs at each one of these number of workers I can hire. Okay. So this first worker, right, adds 1,000 burritos to production, and I only had to pay them. Whoops. I guess I had them all at once. I only have to pay them $2,000. It doesn't matter how many workers I hire. The cost of the building is always the same. If I have one employee or 5, I still have to rent that space, right? But as I hire more and more workers, right, my labor costs go up by $2,000 because it costs $2,000 a month to employ these workers. So I can then think about the total cost at each one of these numbers of workers. It's just adding up the cost of the building and how much I'd be paying my labor. So I can start to see that my total costs are increasing by $2,000 for each additional unit that I want to hire. So this is kind of an easier one. In terms of that, the marginal cost, which hold on, we got it here. There we go. Right, marginal cost is very similar to marginal productivity of labor. Right? Anytime we see this word marginal, and we'll start seeing it pop up a lot, we're going to be talking about things on the margin. We've already talked about, people make decisions comparing marginal cost to marginal benefit. Right? Well, firms do the same thing. Right? So right now we're trying to determine kind of what marginal cost for the firm is. So it's going to be the change in total cost divided by the change in output, or kind of have it up here in the slide a little bit differently, change in TC or change in total cost from the change in quantity, right, or change in output. So if I go back here and I think about the different changes in quantity, now it becomes a little bit harder because my quantity jumps aren't one. Marginal productivity of labor is a little bit easier because usually I'm hiring one more worker. I'm not hiring workers in like batches of 5 or 6. But quantity increases can be anything. So if I'm thinking about those first 1,000 burritos, what would the marginal cost be for those first 1,000 burritos? Well, my change in total costs, even if I produce nothing, my cost is still 1,000. So that change in cost was $2,000 divided by my change in output, which is 1,000. Right? So that kind of marginal cost for those first 1,000 burritos would be what, 2,000 over 1,000, so 2. And then I can think about, okay, what about to get to 1,800? Well, now my change in quantity or change in output was only going from 1,000 to 1,800, an increase of 800. But I had to hire that second worker and pay them that same market wage of $2,000. So my new marginal cost would be 2,000 divided by 800, which is a little, what, 2,000 divided by 800 is 2.5. I'm doing math in my head correctly there. So my marginal cost went from 2 to make those first 1,000 burritos to 2.5 to then get to that next 1,800 level. And the reason why we think about this is we know the marginal productivity of labor is declining. So if I'm thinking about my marginal cost is the change in cost over the change in output. At least in this simple example, right? As long as I'm hiring the same type of worker and their wage is constant, my change in cost here, every time I go through, no matter what quantity I'm interested in, my change in costs here are all 2,000, right? Because I had to hire an additional worker. The problem is every time I hire an additional worker, we said that maybe initially, right, they're better. But I think in this case, right, and these are the numbers I gave here, we actually had a case where there was no specialization and it automatically, we started seeing those diminishing returns to labor. So that change in output, right, every time I hire a new worker, the cost is going to be the same. But each worker I hire, the change in output I get is going to be lower and lower. So if my denominator is lower here, what happens to the overall fraction? It's increasing. So because we have diminishing marginal returns to labor, because we know that as we want to produce more and more, as we hire more and more workers, each worker is changing output by a smaller and smaller amount, that as we hire worse quality workers, that's actually going to cause our costs to then increase. Think about it this way: if I hired the best worker, maybe to produce the, I don't know, like something wild, I don't know, they're working with their something like oh, I got an example. So I have a buddy that makes what do they call it? Old hand-made furniture where there's no screws, no nails. You're cutting dovetails and through all this stuff. It's crazy, right? I watch him do it. If he was the first worker hired by someone to make that type of furniture, he could probably churn out, I don't know, let's say he's making tables, maybe he could do like 5 tables a day. So if they're paying him whatever the market wage is, he makes 5 tables a day, great. To get those same 5 tables, if he was hiring me, he would need like 10, right? Because my marginal product was so much lower, so they'd have to hire 10 workers that would greatly drive up their costs to get the same 5 tables, right? So that's kind of the idea behind what's going on. Because we have diminishing returns to labor, we're actually going to also end up with increasing marginal costs. As we want to produce more and more, our costs are going to be higher and higher, okay? So we could kind of think about here, I've got my total costs. I can go through behind each one and kind of talk about this, calculate our marginal costs, right? Look at that change in total costs divided by that change in the quantity, right, going from 0 to 1,000. We go through, do this for every single kind of change in output and can determine the marginal cost at each one of these levels. So we see here, if I actually went through and calculated those exact values, sure enough, because I had diminishing returns to labor, which is where all this data, where all this stuff started, I end up with increasing marginal costs as well. Okay? So as I want to produce more of something, I have to use kind of less and less productive resources, in this case labor, which then drive from my marginal costs upward. Okay. Any questions on that? Okay, I think that's all I want to say here. We've got our marginal cost curve, right? We could plot these points, right? So I could then take different quantities as my X values. Instead of plotting my total cost, I could just plot my marginal cost values. And what I end up seeing is that because I have this nice increasing marginal cost. And in practice, what typically ends up happening is that not only do we have an increasing marginal cost curve, and I'll probably be lazy sometimes when I'm drawing this and it'll look very linear, right? It's usually the case, not that marginal costs are just increasing, and I'll usually keep it linear if we do any calculations just to make the math easier. But more often than not, what ends up happening, right, is yes, marginal costs are increasing initially, right? Maybe if I'm thinking about the handmade furniture, yeah, I can start to hire more and more workers who are kind of pretty good at doing this, right? They have some experience, but eventually, right, I'm going to get to hire more and more workers where I need a ton of them because they don't have any experience, right? They're really low quality. And so we get this really quick, like, upward increase in the slope. We're kind of looking at something more like an exponential curve. But like I said, for a lot of examples I'll kind of keep it linear to make the calculations easy. But we do typically see kind of this slope of this curve start to get greater and greater, right? Or get kind of more and more steep as we want to get to higher and higher quantity levels. And it kind of plays out here, right? First marginal cost went up by 50 cents, then by what? 83, then by $1.67, and then by $5, right? So we kind of see this increasing marginal cost at an increasing rate. All right, so hopefully this one shouldn't be too bad. And this is where maybe having kind of a calculator with you in class, or hopefully your phones can kind of calculate and pull those out. Well, some of the math might start getting a little bit more tricky. Okay? So let's say I have this question. We go back, we think about, okay, I'm producing all these different, different quantities for bushels of wheat, and I've got my total cost of each one of these quantities. So what would the marginal cost of moving from 36 to 51 bushels of wheat be? Right? So I want you to calculate the marginal cost going from that 36th to that 51st bushel of wheat. Give you a little bit of time to work on that one. I think the marginal cost equation is still.
How can you dictate someone's productivity prior to knowing anything? How can you predict? It's like your furniture example. Oh, sure, you can claim that you need more people, but then at the same time, how do you truly know?
Yeah, so I'll kind of, it's a good question. I'll address it because I want everyone to hear my answer. No, it's good. Okay. All right. If you haven't gotten an answer in, take your best guess here. All right. I'm going to close it out. We got 32 people. All right. Yep. Oh. Yeah, I did. I just saw a 33rd person pop up. She had to work. There we go. All right. Close it out. All right. So to find my marginal cost, right? All I'm doing is taking this change in cost of 200 and dividing it by my change in output or my change in quantity of 15. So 200 divided by 15, we should have gotten 13.33. Okay. So all I did there, using that formula, I've got it written on the board, right? Change in cost, I went from 800 to 1,000 was $200. Divided by the change in output, going from 36 to 51, that was just a change of 15. So the question that was asked, I think it's interesting, is how do I know this stuff ahead of time, right? How do I know work with productivity? So generally think about it this way, like in practice, what firms are going to do is they start hiring more and more workers. And then after a month, they see what the output is, right? So I might, continue to hire workers, see what their output is and realize, oh, okay, that second worker, right? My marginal productivity or the marginal productivity that adding a second worker after a month was X, whatever that number is. And then, okay, well, we sold, increased revenue by more than our cost with that worker. So let's hire a third. So it's more like trial and error in practice until they would get to a point where maybe they hire a worker and realize that worker didn't really add anything. And you can make some predictions ahead of time. Like, if I get to this point where I'm hiring that fourth worker, I'm like, man, marginal productivity is really declining. I could get this fifth worker and he or she might be just standing around most of the day, right? So some of it's going to be specific to whatever role we're thinking about, being able to predict what the productivity of adding one more worker is But in practice, it probably is a little more trial and error, right? Kind of the realization of costs. So you had another question as well? Okay. All right, so I went real far. So where were we at? Yeah, we did there. So we're now going to start to think about, okay, we can determine that we've got these increasing marginal costs, right? As I want to produce more and more. So what point do I stop producing, right? Because let's say I can sell a good and make $200, right? Well, as I sell more of it, right, I'm going to have to produce more and more. So if I want to sell more, I'm going to have to increase quantity, which are going to drive my costs up. So at what point do costs get too high that it doesn't justify, right? The cost gets higher than that $200 I can sell it for. Because remember, for the firm, right, what they're thinking about, I want markers over here. The benefit to them is the price they can sell it good for. So to the firm, they want to continue to increase quantity as long as the price they can sell a good for is greater than or equal to their marginal cost. Okay? So firms will decide to produce more, right? Or they'll kind of increase quantity as long as the price they can sell that good for is greater than or equal to their marginal cost. You can't think about there because then I think they're making profit. Right? So we think about what level is it going to be that maximizes profits, ends up being, here we go, right? So we've got total revenue, which is price times quantity. We can then determine where total costs are, right? So as I hire more and more workers, my costs are increasing. If I just take the difference between my total revenue and my total cost, whenever that difference is greatest, well, that's when my profits are maximized. So if we're thinking about profits here, total revenue minus total costs, we know that total revenue is just the price I can sell a good for times quantity. Now, here it's a little bit trickier for the sake of this example. Well, think about if we had marginal costs that were, I guess you want to think about them as constant. That's okay, so that each unit we're producing would have the same marginal cost. We'll just assume that's the case for now, even though we know in practice they're typically increasing, just to make this math. I want to make a point here. So if marginal costs were constant, then to get my total cost, I would just take those marginal costs and multiply by my quantity. So if I rearrange this a little bit, notice I'm continuing to increase profit as long as that price is greater than or equal to, I guess if you write it zero profit, but I continue to increase profit as long as that price is greater than marginal cost. Now, in practice, this won't be a constant, and the math would be a little bit more complicated because we have an actual function that we had to plug in there. But that's the idea about why we're increasing profits as long as the price is greater than or equal to my marginal costs. Now, there will be some point at which the marginal costs go past that price, and any quantity where that occurs, I won't want to produce that much. Right? As soon as I have that marginal cost go above the price I can sell the good for, I want to stop. I want to stop producing it because now it's costing me more than what I can get back in revenues. Okay. So I think I've got, we'll say this next because I do one more thing before we end. So you kind of think about it this way. I'll allude to something that we're going to do in the future. We'll probably see this again, but I want to maybe give a pretty good visual to kind of what I was just describing. So if we see these increasing marginal costs, right, what's going to be true is that if we're in a perfectly competitive market, I have to just sell the price for what everyone else is. If I try to sell a gallon of gasoline for $1 more than everybody else, well, someone's just going to drive half a block down the road and buy it from them, right? So whatever the equilibrium price is for that good is essentially telling me my marginal revenue, right? Each additional unit I sell, increase in revenue will just be whatever the price of that good is. So as long as that price is above my marginal cost, I keep producing more and more, right? I keep increasing quantity because I'm adding more revenue than I am adding costs, right? So if I'm adding more revenue than adding costs, I'm increasing profit. I then go all the way up to the point where price is exactly equal to that marginal cost, or the amount of additional revenue is exactly equal to the additional cost. That's where my profit will be maximized. If I continue to go past that point, well, now I'm just increasing my costs by more than I'm increasing my revenues, right? Or marginal costs are greater than marginal revenues at every quantity past that point. And so we would say for the firm, that would be kind of their equilibrium point. That's the point where profits are maximized, right? Up to the point where marginal revenues equal marginal costs. All right, so either bring those corrections to class on Friday or get them uploaded by the end of the day. If you have any questions related to, what question you got wrong or double check something, feel free to reach out. Other than that, I will see you guys on Friday. Also, if you didn't get your exam kind of Scantron back, make sure you stop by on your way out.